Okay. Um, Let me share my screen here. Is it visible to all of you?
Yes, sir.
Okay. So in the last lecture, we were kind of doing this um, accumulation, which we already did. Now let's move on to some basic signals. And initially, I thought that I will be doing a discrete time signal, and there, how can you, what you can say, and these time operation on basics, sorry, in discrete time signal. But I hope that you will be able to do that. Okay, it's not that difficult. Scaling, shifting, and all that. Okay, you can do that on your own. So let's move on to the basic signals. That is a bit more important. So basic signals. Okay, and you are already familiar with quite a few of them. So the very first one that I'm going to discuss is unit impulse signal. Okay. So, okay. Before that, let's discuss with unit step. It's the easiest one. Okay. Unit step signal. Okay. So most of you are already familiar with this signal. It's not very difficult to understand. So this is a signal which is, let me define it first. So UT is defined in quite a few ways. Okay, let me try to do all of them. Okay, so UT is defined like this, that it is equal to 1 for t greater than equal to 0, and then it is 0 for t less than 0, and this is the most common one. Okay, this definition here that you see is the most common definition of unit step signal. Okay, so let me just kind of do this box around this. Okay. And what does this mean? That UT is discontinuous at t equal to 0. Okay. So in all these definition, actually UT is like that only. Another very common definition that you will see is this, that UT is equal to 1 for t greater than 0. UT is equal to half for t equal to 0, and then it is 0 for t less than 0. Okay, so this is another very common definition that you might see. Okay, so let me do this in the box as well. Now my question is, which one of them is correct and which one of them is incorrect? Hello, which one of them is correct and which one of them is incorrect? Am I audible to all of you? आप लोग बोल नहीं रहे?
Yes, sir.
कौन सा करेक्ट है कौन सा इनकरेक्ट है?
The first one is unit step.
The first one is correct.
And second one? So actually both of them are correct. Okay, as long you see, by any definition, by this definition or even by this definition, by both of these definition, UT is discontinuous at t equal to 0, right? Isn't it? At t equal to 0, there is a jump, isn't it? And if there is jump, it doesn't really matter what is the value there. Are you getting my point? You will never be able to use that value. And that's why people take this. This definition is in accordance with Fourier transform, uh, and all that, but it doesn't really matter. Both of these definitions are equally correct. In certain situation, I have seen that people define UT like this as well. So UT written as 1 and for t greater than equal to 0, and then they have defined it by some other integer, let's say 7 for t equal to 0, and then after that 0 for t less than 0. That is also valid because at t is equal to 0 it's anyway discontinuous, isn't it? So it doesn't really matter what value you give it here. One is never going to use that. So both of these definitions are equally correct, and you will never be asked. So you can see that since you have kind of ambiguity in the definition. Definitions is generally something that is not asked in gate examination. Anything that is ambiguous, gate generally don't ask that. And it's not about the unity step. From signal is a tool that we use to make signal right sided. It doesn't really matter which definition you use, it's still going to be right sided only. Okay, so both of these definitions are correct. Let's move on to the properties of UT. And the very first is that what will happen if we add UT? So UT is, let me draw this and then we should. Okay. So let me draw this UT here only. So UT is a signal which is like this. It's 0, although up to t equal to 0, and after that it takes a step and becomes 1. Okay. So this is 1 here and 0 here, and this point is t is equal to 0. Okay, so at t equal to 0, there is a jump here. Is this clear to everyone? Now let's see the property of UT. So what is UT plus u of minus t? If you add UT plus u of minus t, what is it that you are going to get?
DC signal.
So it's going to be a DC signal only, right? So it will be equal to 1. So you can call this as DC signal. Okay. Is this clear? Second is, what will be the power of UT, or what is the energy of UT? If you compute energy of UT, what that is going to be? What will be energy of UT? You integrate it from minus infinity to infinity, mod of u of t whole square dt. So since it's a real signal, it's basically 0 to infinity only, and ut is 1, right? So 1 for t greater than equal to, before it is 0 anyway. So this is 1 square dt, and you will have t limit 0 to infinity, which is equal to infinity. So energy of a unit step signal is infinite. Okay, means it's not an energy signal. Energy has to be finite for an energy signal. Now what will be the power of UT? What is power of UT, unit step signal? What is power of UT? So if you compute its power, let me just write this. You can write it like this: limit t tends to infinity minus t by 2 to t by 2, and then here you have 1 by t and u of t mod whole square dt, right? This is what your energy definition is. If you follow this, you will have limit t tends to infinity 1 by t, and you are integrating from 0 to t by 2, because before t before 0 it's anyway 0, right? So 1 square dt. So what exactly you have is limit t tends to infinity 1 by t, and if you do this part here, that will turn out to be t by 2. So this is equal to half. Okay. So this is exactly equal to half. So and the power of unit step signal is half. That is something you should also remember. Now coming back to the fourth property, and that is related to differentiation of ut. So if you differentiate ut, I'm just going to write it like this here, dt. This is equal to delta t, unit impulse signal, and I will prove it at some other point. Okay. Uh, Next is if you integrate or accumulate ut minus infinity to t u of t, what this is going to be? This is a function in general, isn't it? If you are integrating all the way up to t minus infinity to t, right? So this is generally a function. So what this is going to be? Can anybody tell me what this will be? Most of you are in third year, right? So you have already seen these things. So when you integrate ut, what is it that you will be getting?
Sir, impulse.
इंटीग्रेट करने पे, डिफरेंशिएट करने पे इम्पल्स मिला ना,
Sir,
इंटीग्रेट
is
करने
it RAM signal?
पे, yes, it's a ramp signal. You see, when t is less than 0, this integration will be equal to 0, isn't it? So for t less than 0, you will be getting 0. When you integrate it beyond t, you will be getting t for t greater than equal to 0, isn't it? And this is the definition of ramp signal. Okay, so this signal is called rt, which is equal to 0 for t less than 0, and for t greater than 0 it is a straight line. So this rt is something like this. It is 0, and then after that it's a straight line t only. So this is t, and here it is 0, and this point is t equal to 0. Okay, so this is ramp signal. Okay, so with this we are going to now discuss unit impulse signal, which is a very simple, actually not very simple, but which is very important signal, you can say. So next signal we are going to discuss is impulse signal, or to be specific, we are going to discuss unit impulse signal t is equal to 0. Unit impulse signal. Okay, and this signal is denoted by delta of t. Okay, how this signal is denoted? Delta t. Is this clear to all of you? And what is the definition of delta t? That delta t is equal to 0 for all time t not equal to 0. Okay, means except t is equal to 0, it is 0 everywhere. And at t is equal to 0, at t is equal to 0, delta t tends to infinity. So its value becomes infinite there. So only this is not just defined by these two. The another thing is that area under this impulse minus infinity to infinity delta t dt is equal to 1. So area of impulse is equal to 0. So it is denoted something like this. So we denote it by a arrow here at t is equal to 0. Okay, and its strength, which is basically what you can say area, is generally given as this. So its area is 1, so I'm just writing 1 here. If its area is 2, let's say it is 2 delta t. Okay, then 2 delta t is also 0 everywhere, and its area under curve is equal to 2. So I would have written there 2. Okay. So this is how we generally denote delta t. Is this clear? And delta t is generally also denoted as a what you can say, as a limiting case to other function. Okay, so it's a generalized function, it's not defined in normal term, and there is actually a generalized function which is kind of part of distribution theory, so we are not going to discuss that, but we will discuss it how this can be written as generalized signal limited. So in limited case delta t is generally denoted like this. So delta t can be approximated with any function that you know. Okay. For example, it can be denoted by, let's say you have a rectangle function. Rectangle, I haven't defined it yet, but I will define it, and most of you probably already know that. So it's not a very difficult thing to do. So another thing is that it can be denoted as limit, let's say tau tends to 0, and you have rect of t by tau. Okay, and its area, what is the area of rectangle here? What is the area of rectangle? Is it will be equal to 1 by tau here, sorry, tau here, right? So you multiply that with 1 by tau, and this is your impulse signal, and let me show you how. So this rectangle, rect t by t, will be denoted by this. Let me just draw that. So this is your rectangle. Its height is equal to 1, and its duration is tau here. So actually it's starting from this point, so this is minus tau by 2, and this point is tau by 2. Okay, and its height is 1, right? But here we are defining this 1 by tau, right? So its height is going to be 1 by tau now. Okay, and you can see that its area is equal to 1, but as tau tends to 0, this becomes larger and larger and larger, isn't it? So it will kind of, as tau tends to 0, as tau tends to 0, this will become like a line. Okay, and its area is still going to be 1 only, no matter what is the value of tau, it's always going to be 1. But its width, which is directly tau, as you make this 0, it will become kind of 0. Okay, or tends to 0 only. Okay, is this clear to everyone? So this is how you can define rectangle. You can define rectangle as a limiting case to other functions as well. So delta t can be even written as like this: limit, let's say again I will be using this tau only, or let me use a there. A tends to 0. Okay, so it is going to be 1 upon a e to the power minus at u of t. Okay, as a tends to 0, you see, you know that its area of e to the power minus at ut is equal to how much it is? 1 upon a, isn't it? Okay, sorry, sir. I should have defined it a bit more carefully. Let me define it like this: a e to the power minus at ut. Okay, so as a tends to 0, what will happen? Its area is anyway equal to 1, but as a tends to a tends to infinity, not 0. It tends to infinity. As a tends to infinity, here what will happen? Its height is going to become infinity, and this is its area is still going to be 1 only, isn't it? So this signal, which is something like this, which is actually like this only, and this point here is equal to a, and as a tends to infinity, it will start, it's going to go upward, but its it's going to become 0 very quickly, isn't it? And so it will also turn out to be like a uh, impulse only. Okay, so delta t can be expressed as a limiting case to many other functions as well. Okay, but as you know, as it is written in quite a few books, you will see that we are not interested in delta t, but rather than we are actually interested in the properties that it has. Okay, so its properties are more important than the delta t itself. Okay, so let me just go ahead with the properties. And the very first property of delta t is that it's an even function, that delta of minus t is equal to delta t only. So it is an even function. Okay, even function. Next property that we are going to discuss about delta t is that okay. Um, so next thing that we are going to discuss about its area under curve, which is already given. So I will just elaborate here that let me just define epsilon here. So epsilon minus epsilon to plus epsilon delta t dt is equal to 1. Okay, and where epsilon is a small positive number. Okay, so delta is absolutely located here at t equal to 0. So this is our delta t. Let me just draw this. And if you are integrating, no matter what is your range, as long as this t is equal to 0 is under that. Okay, so for example, let me ask you question and that will be much better. So example 1, let me say. So if we have to find out this minus 10 all the way up to 2 delta t dt, what is this value going to be? From minus 10 is somewhere here, isn't it? And 2 will be somewhere here. So if you are integrating from here to here, you see that you have already encountered delta t, isn't it? So whatever its area is, that has been counted now, isn't it? So what will be this value? Can somebody tell me?
So is it 1?
It's 1, right? Because area of delta t is equal to 1 only. Right. Let me ask you another question in the similar line. If you are integrating from, let's say, minus 3 to 1 and you are uh, doing this 2 times delta t dt, what this value is going to be?
0.
So 2.
Why 0?
No, sir, 2, 2.
So it will be 2 times minus 3 to 1. 2 times delta t is basically as it is, it's equal to, you can write this 2 times, isn't it? This function. 2 is a constant, you can take out, and minus 3 to 1. Delta t is located at 0. So between minus 3 and 1, you have 0, isn't it? So this will be equal to 1, and you already have 2. So 2 times 1, that is equal to. Let me ask you another question here. Minus 30 to 3, sorry, to minus 3, delta t dt. What this is going to be equal to?
0.
It will be equal to 0. Why it is 0? Can anybody elaborate? Because between minus 30 or minus 3, your 0 is not located there, isn't it? 0 is located after 3. So from minus 3, isn't it? So minus 30 से minus 3 के बीच में 0 नहीं आता, इसलिए you have not encountered this functions, this area, isn't it? So between that it is anyway 0. So its area will be 0. Let me ask you the similar question. Let's say 2 to 20 delta t dt. What this is going to be equal to? Can anybody tell me?
Zero.
It's also going to be 0 only, isn't it? Because between 2 and 20 you again don't have 0 there. So this is going to be 0. Okay, I hope that this is clear to all of you. Now next move on to a next property, and that is scaling of delta t. So scaling, and we are going to discuss time scaling. So what is delta of at? That is the question. What is delta at? So we scale delta t, what we are going to get? Anyone?
Delta t plus theta. Zero.
No, no. So this is actually equal to.
Delta T only.
No, no. It's equal to. I will prove this. Let me just write this for the sake of definition. This is 1 upon mod A delta t. What is this? 1 upon mod A delta t. And why it is like this? Let me use this definition of rectangle only. Okay. So what is delta t? How delta t was defined? How we have defined delta t in the very first case? You see here. It was tau, limit tau tends to 0, 1 by tau rectangle t by tau, isn't it? So let me just use that definition. So this is limit tau is equal to tends to 0. What we have? Tau times rect of rectangle of t by tau. Okay. Is this clear? Isn't it? This is the definition that we have used for delta t. Now what will be from this definition only, what is going to be delta of at? It's going to be limit tau tends to 0, tau only rectangle. आपको t की जगह पे क्या लिखेंगे हम? at, isn't it? By tau. Can we write this? डेल्टा ऑफ at को हम लोग ऐसे लिख सकते हैं कि नहीं? हेलो, can we write it like this or not?
Yes.
Yes. Okay. And now just look at this. Let me just kind of modify this as well. So limit tau tends to 0. We have tau, and let me just slightly modify this. Instead of t को ऊपर रहने देते हैं और नीचे क्या लिखता हूँ मैं? Tau by a. Okay. This is like this. So this rectangle will be something like this. It will be from here to, let's say, here, and okay. And what is going to be this point? Initially it was tau by 2. Now it is going to be what? Minus tau by 2a, and here it is going to be tau by 2a. Is that clear? And height is still going to be 1 by tau only. So what is the area of this rectangle? Can anybody tell me? ये रेक्टेंगल का एरिया कितना होगा? इसका हाइट टाउ है और विड्थ कितना है? टाउ बाई ए है. आर यू गेटिंग माय पॉइंट? इसका विड्थ कितना है यहाँ से यहाँ तक? टाउ बाई ए, इजंट इट? तो कितना होगा हाइट इसका? कैन समबडी टेल मी?
फिर एरिया टाउ स्क्वायर बाय ए होगा.
सॉरी दिस इज सॉरी 1/tau. अगेन 1/tau था ना वहाँ पे. 1/tau सॉरी, यहाँ पे टाउ लिख दिया मैंने गलती से. So this is, sorry, instead of tau this is 1/tau. So let me just get rid of these 3 and write 1/tau here. 1/tau, this is 1/tau, and this is 1/tau. Okay, and this is also 1/tau only. Now tell me what is the area here.
1 upon a.
1 upon a, right?
Area equal to A.
Area will be equal to 1 upon a or a. 1 upon a ही होगा ना. Tau by a times tau. So that is equal to
Yes, sir.
1. So 1 by a only, isn't it? Now tell me whether area will be positive or negative. Even if a is negative, let's say a is equal to -2. Okay. Then इसका area कितना होगा? Positive 2 आएगा कि negative 2 आएगा?
Sir, area will be positive.
Area will be positive. Why? Because this is a event signal, isn't it? ये event signal है. ये निगेटिव, ये इधर की जगह इधर हो जाएगा, ये इधर की जगह इधर हो जाएगा, लेकिन उससे ये नीचे की तरफ थोड़ी आएगा. Are you getting my point? So area will be positive. It means its area will be equal to 1 upon mod A, no matter whether A is positive or negative, right? So you can see previously it was when the area was equal to 1, we got delta T. Now the area is equal to 1 upon mod A. And it's still when t tends to 0, when tau tends to 0, it's still going to assume the, what is known as impulse only, isn't it? So this can be directly written here as its area is 1 upon mod A. So we are going to write it like this, and this is going to become eventually a impulse. As tau tends to 0, its height is going to become infinity, and its width is going to become 0, isn't it? And its area is going to become 1 upon mod A. So we have amounted that by 1 upon mod A, and to impulse we will be writing this as delta t. Okay, so this is delta of AT. So delta of AT is equal to 1 upon mod A delta t. Is this clear to all of you or not?
Yes, sir.
Okay, so
Yes,
it's a pretty different kind of function, and you have to understand it properly, okay? Because these property can be used anywhere. Okay, so this is the second, third property, whatever property number I forgot anyway. So let's move on quickly to the third one, and that is known as okay, so the next we are going to discuss is delta of t minus t naught. So when you shift this, okay, I mean shifting is very easy. So this is located now at t is equal to t naught, isn't it? Its area is still equal to 1, but now it is located. So this is impulse located at which point? कौन से पॉइंट पे लोकेटेड है? t is equal to t naught, right? So let me just give you a one or some very basic problem on that only. Okay, so what we have is minus infinity to 7, and we have delta of t minus 8 dt. What this is going to be equal to? Can somebody tell me?
Sir, impulse at 8.
But I am integrating it from minus infinity to 7. So you should get some value, whether you will be getting 0 or 1.
0.
0.
Why 0? Why 0? We will get 0 because we are integrating from minus infinity to 7 and impulse is located at 8, isn't it? तो आप 7 तक इंटीग्रेट कर रहे हैं, 8 आया ही नहीं. So that's why this will be equal to 0. Is that clear to all of you?
Yes, sir.
Another important property with reference to delta t is this: ft times delta of t minus t naught is equal to ft naught into delta of t minus t naught. Okay, is this clear? So when you multiply impulse with any function, okay, what will happen? Any signal को आप अगर multiply करें delta t minus t naught से, so you see that delta t minus t naught is 0 everywhere except t equal to t naught, isn't it? So everywhere this ft is going to be 0, and its only value that is going to be counted will be at t equal to t naught. So at t equal to t naught, strength of impulse here is equal to 1. When you multiply this with ft, its strength is going to become higher, and that will be equal to the value of the function at that point. So ft naught. Okay. So you can see that this is your function, and let's say you are multiplying this with the impulse which is located at this point. Okay, let's say t is equal to t naught. Okay, I'm not drawing this to scale, t is equal to t naught. Now you can see that what will be the resultant? Resultant will be an impulse only, isn't it? क्या होगा इसका result? ये everywhere this is going to be 0, right? Because this is 0 everywhere except t is equal to t naught. So when you multiply this function, no matter what is its value, अगर आपको हर जगह पे क्या होगा, 0 से मल्टीप्लाई कर रहे थे, everywhere it is going to become 0 except at t is equal to t naught. और t is equal to t naught पे इसकी वैल्यू क्या है, इस सिग्नल की वैल्यू, इसकी वैल्यू क्या है, ft naught, isn't it? एंड इसकी वैल्यू क्या है, इसका एम्पलीट्यूड, सॉरी इसका जो एम्पलीट्यूड तो इन्फिनिटी है, लेकिन इसकी एरिया 1 है, isn't it? So you are basically multiplying this one with ft naught, that will become ft naught. Okay, and let me make this under bracket. Okay, so this is what you will be getting. Is this clear? Okay, and one continuation of this, the same property is another property here, and let me just describe that. So we have minus infinity to infinity ft delta at plus t naught or something like that dt. So what this is going to be equal to, can anybody tell me? Okay, so we will kind of find these kind of value. Don't worry, let me give you problems and that you can try. Okay. So whenever we will apply property, let me just tell you. So जब भी हम delta t की property लगाएंगे, the first thing that we will be doing is scaling. सबसे पहला काम क्या है हमारा, scaling करना. Okay, and then after we will apply this second property is known as sampling. So this property here is known as sampling. Okay, you are getting a sample of ft at t equal to t, right? So that's why it is called sampling. And after that you will be applying sampling. And third आप क्या लगाएंगे, area. Okay, so if you get some problems, always remember that very first thing that you will be doing is delta t में a जो है उसको बाहर लाओ, उसके बाद उसका सैम्पलिंग करो और नेक्स्ट में एरिया निकालो. Is this clear to everyone? Can you remember what is the order of operation? So your order of operation is like this: first scaling, then sampling, and then area. And let me give you some problem based on this. So let's say you have to find out this value, minus infinity to plus infinity. You have been given sine 2 pi t, okay, plus pi by 2 multiplied with delta 2 t minus pi by 3. Sorry, let me just 2t minus pi by 3 and then dt. What this value is going to be? Can somebody tell me?
One upon two sine 2 pi t plus 5 by 2.
Okay, I don't know. Let's just check that out. So what this is going to be? Let me just do this. So very first thing that we will be doing is we will be first scaling this delta t. So let me just write this function as it is, sine 2 pi t plus pi by 2, and here we will be having, I will take this 2 outside, so what I will be getting 1 upon 2 delta t, and when I am taking 2 outside, 2 इससे भी आएगा, isn't it? So what you will be having pi by 6. Are you getting my point? Is this clear? In the next step, I will take half outside. I will put it like this, minus infinity to infinity. Now this delta is located at pi by 6. तो t की जगह हम यहाँ पे क्या लिख देंगे? Pi by 6. Sines 2 pi, and I will have pi by 6, isn't it? And then plus pi by 2, and here I will have delta t minus pi by 6 dt. So you know its area is going to be 1 only. So let me take half and this function outside, and rest of the thing is going to be, that's area is anyway equal to 1. So let me just write this sign. So pi square divided by 6 plus pi by 2. Okay. And here you have minus infinity to infinity delta t minus pi by 6 dt, and you know that this area turns out to be 1, so answer will be half of sine square, sorry, sine pi square by 6
Sir,
plus
it should
pi,
be pi square by 3.
हाँ पाई स्क्वायर बाई 3 हो जाए, 2 है ना यहाँ पे 6, दिस विल पाई स्क्वायर बाई 3 and here pi square by 3 pi by 2 only. Okay, so this will be the answer. Okay, let me give you another problem that you can practice again. So the next problem is a bit more simpler. What we have is, this is another problem, is minus infinity to infinity, and here you have under square bracket 2 cos t by 2, okay, plus t square, and this times delta t minus pi. Actually it's okay, t minus pi dt only. Okay, find out this value, what this is going to be.
It should be pi square. Guys, you have to be fast, right? Don't have to lift the pen, right?
Pi
To for this kind of question? It should be pi square, right?
So this is directly equal to 2 cos pi by 2 plus pi square. Pi by 2 is anyway 0, isn't it? So this will be equal to pi square. Okay. You have to be very efficient in solving these questions, okay? And you have to practice as much as you can. So let's move on to we have already discussed this impulse now, and let's move on to unit ramp signal. Unit ramp signal. And unit ramp signal is written as RT, and this is actually T times UT. Okay. Or you can write it like this, that this is equal to T for T greater than equal to 0, and it is 0 for T less than 0. And it is plotted like this, that it is 0 at all the way up to T, and after that it's a straight line, and the equation of that straight line is T. Okay, so this point here is T is equal to 0. Before this it is equal to 0, and after that this is equal to 0. Okay, so this is RT. Is that clear to all of you? And
Yes, sir.
okay, I'm not going to into the property of this function. You can actually go on your own. Next, I'm going to discuss a rectangular function. And instead of writing function, I am going to write this as pulse, because it is just a pulse only. Okay. So rectangle pulse is defined like this, that it is between symmetric limit. Okay, and it's 0 everywhere. So this point, let me write this T by 2 minus T by 2. This is T by 2. And this, let me write this A. So this rectangle pulse is denoted by A rect T divided by capital T. So you see that capital T is actually its width. So T divided by T, this capital T denotes that its width is equal to T. Is this clear? And this A denotes that its height is equal to A. Is this clear? So this is how your rectangle pulse is defined. Similarly, you have your triangular pulse, symmetrical triangular pulse as well. And triangular pulse is defined like this. Let me just do this. Okay. But you will see that whenever you will get these functions, their definition will be given by gate as well. Okay. They will not leave it to the, because this is not a standard definition of rectangle or triangle. Okay. Everybody defines them in their own way. So if the gate is going, if you ask, gate is asking you this question, it will also ask you. So between T to T, okay, and it's again written as only a triangle TRI and A by capital T. Okay, you see that its width is 2T, but its actually effective width is T only. So that's why it is written as T. And what is effective width? Let's assume that it was a rectangle and has the same area as this one. Then it will be this rectangle, isn't it? It's what will be the area of this triangle? Half into A into 2T. So that is the AT only. And area of this rectangle is also AT only, isn't it? So you see that if it was a rectangle of the same area, its duration will be T only and not 2T. And that's why it is divided. Here it is written in division as T only. Okay. So this is something that you can kind of get aware. This is how I define it. But you see that when this question will be, this kind of question will be asked in GATE, they will either give you a picture or they will clearly define it. Okay, what they mean by this triangular pulse. Okay, so there is no point into going into all of them. I have already discussed them while talking about energy and power and all that. Okay, so next up we have uh, sync function. Raj, are you there?
Yes, yes, yes.
So are you going to discuss sync?
I think we have one video. Should we circulate this video for sync? It will be more better because it's almost 1 hour video. So they will get
Sync.
more idea. Till then we will circulate it, and in the next if any application will be there, then we can discuss that. I mean, so I will share the link of that sync function.
Okay.
I
Okay.
think
So
instead of discussing this in class, they will
okay.
watch this video on that sync. They will get more idea in that.
Because sync is anyway very big path. There are so many properties, and another thing is that drawing it is a difficult task, so it takes quite a lot of time there. Okay, so you can watch that video and learn about sync. Sync is also a very important function. Now
See this.
I'm going.
The sir that sir was talking today, this standard signal, no, so these signals are very very important signals as a in communication. Also you are going to use it a lot in many subject. You will be using this signals like impulse, unit step, ramp. It has not so much application, but it is there in control system. Then this rectangle pulse, we use it a lot in communication. And then sync function, I think it is the most important I should say function, which we communication guy use a lot, right? So don't forget to watch that video. I will share the link, maybe in the next gate class or in the WhatsApp group. You watch that video on sync function then. Okay, sir, continue.
Okay, so now I'm going to discuss about system. Okay. So what is system? Can anybody tell me? You have to be proactive. Okay, you can't be just sitting there and watching it like a video. Okay,
Convert one form of signal into other.
convert one form of signal into other. Very good. That is a good definition. Okay.
तो एक
So
छोटा सा रिक्वेस्ट है आप लोगों से कि आप लोग एक्टिव रहिए क्लास में, है ना, बातें करिए. ये हम लोग नॉर्मल लेक्चर तो नहीं हो रहा है ना, गेट की क्लास है, तो आपको थोड़ा फास्ट होना पड़ेगा और you have to be that much active in the class. So everybody should talk.
okay, so system. What is system? System, wherever there is a input output relationship, that is going to be called as system. Okay. So whenever there is a input and output relationship. Okay, so system is let me denote it by T. Okay, so what is this T? Let's say you have I'm going to call input as xt and output as yt. Okay, from now onwards, whenever I say xt, it means input signal, and when I say yt, it means output signal. So what is your system? System is a entity which is kind of mapping this xt to yt. Okay, so you can think of that as a mapping only. Okay, is this clear to everyone? So you can write here that
So,
your output yt. Yes.
so can we say that the system is interface between input and output?
Yes, yes, it's an interface between input and output. You can say it's a relationship that governs, that relates input and output. Okay, wherever there is two things, one is input, another is output. One is cause, another is effect. So this is also called input, is also called cause in many of the cases, and yt output is also called effect. Wherever there is cause and effect relationship, wherever there is an input and output relationship, that is going to be called as your system. And this relationship may or may not be what you can say explicit. It may be implicit relationship. Okay, so it doesn't, for example, you can have x t y square t, and that is equal to, let's say, dxt by dt, and then you must have some, let's say, yt here, something like that. So you see that this is an implicit relationship, you cannot really separate them. Okay, but here is a relationship between input and output. So these kind of relationship is always going to be called as system. Okay, and let me just go ahead here. So yt can be written here as t, where t is the mapping, okay, of xt, and xt is your input signal. Okay, so this t is called system, and more specifically it is called system description. Okay, so this is description of the system, that this is the mapping. Okay, system is anyway entity, isn't it? So this, you can call it system only, not confuse it by system description. Okay, so there are many multiple ways in which system will be represented, but for us it's a black box which kind of maps input to output, relates input to the output. Okay, so you can think of it like this. Okay, and there are different properties that system has to obey. Okay, so now we are going to discuss what is called as input and output relationship of the system. Input and output, a description of the system, of the system. So in this description, what happens is that input and output both will be given, and they will be given in symbolic form. As I told you that I will be assuming xt to be input and yt to be output. So one of that relationship, one example, let me just give you some example. So here your output yt is written as 2 times xt. Okay, another system is, so what kind of system is this? First, have you seen this system anywhere? आप लोगों ने देखा है इस तरह का सिस्टम? And this is the
दिमाग पे
system.
जोर लगाओ ना, 2xt कहाँ पे मिलता है? It's not like amplifier.
Yes,
Input
sir.
दिया, multiply होता है, amplifier है.
Amplifier,
It's
isn't it? And xt लिया और xt का मॉड निकाल दिया, ये सिस्टम कौन सा है?
ये बताओ कौन सा है? कोई डिवाइस देखो, कैपेसिटर, इंडक्टर,
Have you
क्या है?
seen any device which works like this? कि इनपुट मिला आपको और इनपुट का मॉड कर दिया उसने?
क्या है
Full
देखो?
Rectifier.
फुल वेव रेक्टिफायर.
full wave rectifier, isn't it? Okay, are you getting my point? So there will be again, as you see that it is kind of abstraction of the system, because this can be a mechanical amplifier, isn't it? It can be an electrical amplifier or it can be a mechanical amplifier. Are you getting my point? Mechanical amplifier भी तो हो सकता है आपका, जिसमें आपने, let's say, you have given it like you have given of omega speed in one wheel, and दूसरे wheel में 2 omega speed आ रहा है आपका, isn't it? Are you getting my point? So it's kind of abstraction here. We are not going into individual system, but we are just going to look at how input and output is related there in that particular system. Yes, somebody was saying something. Hello. कुछ कह रहे थे आप?
नहीं, you continue.
Okay. So next up we are going to discuss how to classify them. So classification of the system. Okay. So next topic is this one only. We are going to classify the system.
और इस टॉपिक से बहुत क्वेश्चन आते हैं फ्रॉम द क्लासिफिकेशन ऑफ सिस्टम्स, राइट?
Yes.
Listen properly.
classification of the system. Okay, so I hope this is going to be clear to all of you. Okay, so whenever we are going to classify, let's say we classify class. आपके क्लास को हम लोग कैसे क्लासिफाई करते हैं? Okay, we classify your class into girls and boys, isn't it? So we take one property, that is gender, and based on this gender we are classifying students either into boys or into girls, isn't it? Are you getting my point? So classification works like this only. You take one properties and say whether someone is satisfying this property or not. Okay, so based on that you will have your classification. So basically what we have to discuss is these property only. So the very first property that I am going to discuss is going to be called additivity. Additivity. Okay. And what we mean by additivity is that you have your system, and if x1t is your input, and because of x1t input your output is, let's say, y1t, and when x2t is input your output is, let's assume that it is equal to y2t. Then according to this additivity uh, uh, property, if you give input as x1t plus x2t, then your output must be y1t plus y2t. And let me just get rid of this, it's kind of confusing. Okay, so if x1t gives y1 as output, y1t as output, x2t gives y2t as output in your system. Let me mention t here to denote that it is the same system. Okay, then your output must be, आपका क्या होना चाहिए, y1t plus y2t होना चाहिए, x1t plus x2t जब इनपुट दिया आपने तो. Is this clear to everyone? Then your system is going to be called additive. Okay, and if this is satisfied by the system, then the system will be called, if this is satisfied by the system relationship, then your system is additive. Is this clear to everyone?
Yes, sir.
So let's see one example. We have a very simple system here, and the system is given by, let me just write this. So system here is given by yt, that your output is equal to your input only. Okay. Tell me whether this system is additive or not.
So yes, it is additive.
It is additive. Why it is additive? Let me just tell you this. कि x1t आपने इनपुट दिया सिस्टम को, what you will be getting here as, let's say, y1t, and what will be the y1t here equal to, आउटपुट क्या है, इनपुट के बराबर ही है, तो इनपुट क्या है आपका यहाँ पे x1t, so y1t will be equal to x1t. Let's say you have given x2t as input, your output is going to be, let's say, y2t, then y2t will be equal to what, x2t, isn't it? इनपुट के बराबर ही है आपका सिस्टम. क्या बोल रहा है ये, कि our output is equal to input only. Okay, there is no change in input. Input is as it is provided at output. Okay. Now, if you give x1t plus x2t as input to the system, okay, let me assume that output is y dash t. Okay, then y dash t will be equal to what? Your input only. And what is your input? x1t plus x2t, isn't it? So from here you can see that this x1t can be written as y1t plus y2t, isn't it? So your output is equal to y1t plus y2t when your input is x1t plus x2t, isn't it? This means that your system is additive. This means that system is additive. Let me give you another example here. That output is given in the system description is given by this, that output is equal to xt plus a number 3, xt plus 3. Tell me whether this system will be additive or not.
Sir, not additive.
It will not be
Not
additive.
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 Why? So let me again try this problem in the same manner. x1t. Okay, when you put x1t as input, let's assume that output is y1t. Then what will be y1t? Your input plus 3, isn't it? So input is x1t and plus 3. You have second input. Let me assume this x2t. So what will be the output? Let me assume that to be y2t. And what will be y2t here equal to in this case? Input plus 3, isn't it? So input is x2t plus 3. Now let me give the system input as x1t plus x2t. So, and let me assume that output here is y dash of t. So in this case you can see that what is going to be your output? Your output will be equal to input plus 3, isn't it? x1t plus 3, sorry, x1t plus x2t. This is your input and this plus 3. And you can clearly see that this is not equal to y1t plus y2t. Is it equal to that? No, because y1t plus y2t will be equal to x1t plus x2t plus 3 means 6, isn't it? And here you have only 3. So then because of this added constant, your system becomes what it becomes? Non-additive. Okay, so it's not an additive system now. Okay, so system. So let me just write here, the system is not additive. System is not additive. Okay, let's move on from here. So we have already discussed additivity. Let me just discuss another property that is called scalability or homogeneity. Okay. Okay. So second property that we are going to study is homogeneity or scalability. Or simply homogeneity. So what it says that if x1t, sorry, if xt gives you the output yt, then if k times xt gives you the output k times yt, where k is just a constant, where k is a constant, may be real or complex. It can be anything. Okay. Then if then system is going to be, then system will be homogeneous. ओके सो अगर आपका xt है इनपुट, आउटपुट आ रहा है yt, तो kxt जब आप सिस्टम को देंगे तो आपका आउटपुट क्या आना चाहिए, k टाइम्स yt ही आना चाहिए. इज दैट क्लियर? So let's start with the simplest problem possible, that your output is equal to input only. Tell me whether this is homogeneous or not. Tell me if the system is homogeneous or not. So you see here that
Homogeneous.
homogeneous, right? So when you give xt as input, what will be you be getting? Yt, and yt will be equal to xt only, isn't it? So if you give k xt, let me assume that output is something like y dash t. Okay, so you see what will be y dash t? Your system says that whatever is in output, that is going to be the output. It will be kxt, isn't it? And kxt is basically k times yt, isn't it? So when you are giving kxt as input, you are getting kyt as output. It means system is homogeneous. So this is okay. Next, let me give you the second example. Yt is equal to xt plus 3. Tell me whether the system is homogeneous or not.
Not.
So this system is
Non-homogeneous.
so this system is not homogeneous, we are saying. Let's just check that again. You are giving xt as input. What will be the output that you will be getting? Yt. And what is yt equal to? Input plus 3. So xt plus 3. If you give input as kxt, what is going to be output? Let me assume that is equal to y dash t. Then that is equal to, क्या मिलेगा आपको? k xt plus 3. You can clearly see that this is not k times yt, and this is not equal to k times yt, right? Because k times yt will be equal to what? Kxt plus 3k. Here you are getting kxt plus 3 only, not 3k. So that's why this is not equal to kyt. So this is not homogeneous. Okay. Let me give you another problem here, though that is. So let me give you another problem. Here you have output yt is given as real part of xt. क्या मिला है आपका? आपका क्वेश्चन क्या है? Can you understand this problem? Your output is equal to real part of input only, because input can be complex, isn't it? Input is a signal. Signal can be complex. So just tell me whether this system is, and tell me about both, whether this is additive or not, or whether this is homogeneous or not.
Additive and non-homogeneous.
It is additive. You are saying that it is additive, right?
Yes,
And not
sir.
homogeneous. Anyone else? So this system is actually going to be additive. Let's see that. So first we are going to check for additivity. Okay. So if you give x1t, what you will be getting? y1t. And what will be y1t? It will be real part of x1t, isn't it? If you give x2t as input, what you will be getting? y2t, and y2t will be equal to real part of x2t. If you give x1t plus x2t as input, your output, let me assume that it is y dash t, then y dash t will be what? Equal to what? Real part of x1t plus x2t, is it? x1 plus x2t ka real part, and this means that it is equal to real part of x1t plus real part of x2t. Can you see this? It means it is equal to y1t plus y2t. So this is homogeneous. Means this is additivity. So this is clear. Now let's see whether it is homogeneous or not, isn't it? So it's much easier to show it. You can use any counter example here. Okay. Let's take constant k as 2 times j, right? So when you are giving xt, what is the output? Yt, and that is equal to real part of xt, isn't it? When you are multiplying this with kxt, what is going to be your output? Let's say that is y dash t, and y dash t will be what? Real part of. So let me just write this as x r of t, real part only. Okay. So what is going to this? What is it that you will be getting here? Real part of k xt, isn't it? Right? So that is going to be equal to what? This is going to equal to what? K is 2j, isn't it? So you will have, let's say xt is equal to xrt plus j xit. So you are basically multiplying kxt, multiplying with 2j. So if you multiply that with 2j, what will happen? You will have imaginary part, isn't it? And that is not equal to k times real part. Imaginary part is equal to k times real part? No. Okay. So this I can directly write it here based on this logic, that it is not k times real part of xt. Okay. So that's why this is not a homogeneous. Not homogeneous. Okay. So we will see quite a few examples like this in the next lecture. Today I'm going to end the session here. We will meet tomorrow at the same time, and we will discuss about more about all these properties. Okay, is that clear to everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
So we'll meet in the next lecture. Thank you for joining in. All of you can go now.
Thank you, sir.